Hello everyone, welcome to the pharmaceutics class. Today we'll discuss about the HPLC LCMS buffers. Why they have been used in chromatography as a mobile phase. So today we'll discuss everything about the buffers. So what is a buffer? A buffer is a kind of solution like so suppose this is buffer. The buffer is a solution. Okay, this is a solution with a specific pH of 4. So in this particular solution, I'm adding acid or base, and after addition of acid or base in a small amount, the pH is not getting changed. Okay, I have taken a solution which is having a pH of 4. Okay, and I have added a small amount of acid or base, and pH is not getting changed. It is still 4. So this kind of solution, okay, called buffers. They are majorly made up of weak acids and their conjugate bases, and these are essential in HPLC and LCMS to stabilize the pH, and like why it is necessary to get the reproducible retention time and results. So for example, like we are developing a method for paracetamol, which is also known as acetaminophen. Okay, this is a weakly acidic drug. This paracetamol is a weakly acidic drug which is having the pK value of 9.38. So this pK means pH at which 50% of this molecule will be ionized. As you can see, you can see the phenolic OH group. Okay. So because of this is a weakly acidic drug, and this will ionize at pH 9.38. It will be in 50% ionization state and 50% unionized state. Okay, so as we know, the ionized drug, like if you have same drug but ionized drug, if it is in ionized form, it will behave like a hydrophilic drug. Okay, because of mistake I have written here lipophilic, but ionized drug will behave like hydrophilic, and this unionized drug will behave like lipophilic. Okay, so same molecule can behave differently in a single column. Okay, so suppose I am using C18 column and my drug is ionized, so it will not interact with my C18 column as its physiochemical property has been changed because of the ionization. So what do I want? I want like my drug should be in either ionized form, either unionized form. Okay, got it? So because of this reason, you can say this is the monograph of paracetamol, USP monograph. In this they have used this composition, and the pH of this buffer is around 7. Like if I'll use the buffer of pH 7, like 2 unit less than the pK, so most of the drug will be like 99% drug will be in unionized state and 1% of drug will be ionized state. So like most of the drug, like 99% of the drug will have the one physiochemical property, like they behave similarly. So in this like 99% ionized drug, we will get a sharp peak like this one. So now we'll see the mechanism of action of buffer. So this is a very typical example of buffer. So buffers are composed of like weakly acids, like this is the weak acid and this is the salt of its salt. Okay, so we all know weak acids, they do not completely dissociate. Okay, they dissociate partially. Like if I'm taking 10 molecules of acetic acid, so 5 will dissociate and 5 will be remain. Okay, so they will maintain equilibrium, and this when I have taken this sodium acetate, this will dissolve and form sodium acetate and this acetate ion and this sodium. So if I have dissolved this like sodium acetate and acetic acid in a solution in a water, so what will I get? So in my solution, these things will this free acetate ion, this sodium acetate, this sodium and the H plus, and because of the H plus, this solution will impart some pH. Okay, so in my this in this buffer solution, what will be there? Like acetate ion will be there, acetic acid as such will be there, this H plus ion will be there, then sodium ion will be there, and the pH of this solution will be due to this H plus. Okay, and in this buffer solution, how this solution resist pH change we can see. Okay, whenever I'm adding some small amount of acid, okay, this acid will react with this acetate ion. Okay, as I told, this is a reversible reaction, so this H plus ion will react with acetate ion and it will form I forgot here, it is acetic acid. By mistaken I have written formic acid, but it will form acetic acid, CH3COOH. Okay, and once I have I have added base, so base will react this acetic acid. Okay, it will react with acetic acid and it will take hydrogen from here and it form acetate ion and water. Okay, so technically, like the base is coming here, okay, to neutralize acid, free H plus ion. So it is reacting with free H plus ion and forming a water, and the H plus ion which is getting reduced, how it will come back, by this ionization of this acetic acids. Okay, so in LCMS or in HPLC buffer, like whenever we are preparing buffer, so acetic acid buffers they are generally not used, so people are using like different buffers like ammonium format buffer. So I'm giving one example of that. So ammonium format, okay, so ammonium format, if we are taking ammonium format alone, okay, so once we are dissolving ammonium format in a water, it will dissociate in ammonium and acetate ion. Okay, so this ammonium act as like in our solution we have two things, this ammonium and uh, this format. Okay, this ammonium and this format. So suppose this is ammonium, I have dissolved ammonium format in water, now I am getting this ammonium ion and this format ion. Okay, once I have added HCl kind of thing, like I have added HCl from, so from HCl H plus is coming and it is reacting with the format ion and it is getting converted into the format. So because of this no H plus is increasing in this solution, and this is why that is why we are not getting any change in pH. Okay, and once we have added the NaOH in this, the NaOH will react with ammonia. Okay, it will take one hydrogen from this ammonia and it will convert this ammonium into ammonia and water. So here we can see no OH is coming, no H plus is going out. Okay, so because of this it is retaining its pH. But the problem is there is a limitation. Suppose we have taken like 10 moles of 10 mole, we have in our buffer solution we have done 10 molecules of this ammonia and 10 molecules of this format. Okay, so if I'm adding 12 molecules of HCl, okay, if I'm adding 12 molecule of HCl, like just give me a second. Okay, suppose I'm having this 10 molecule and I'm adding 12. Okay, 12 molecule of HCl, 12 of molecule. So this 10 molecule of HCl will react with 10 molecule of format and it will convert into the 10 molecules of this formic acid. Okay, remaining 2 H plus, okay, remaining 2 H plus ion will change the pH of the solution. Okay, that is why one term is coming, that is called buffer strength. So whenever people are preparing mobile phase, okay, in that they prepare like different strength of mobile phase, different strength of buffer like 10 millimolar, 5 millimolar, 20 millimolar, okay, 50 millimolar. So as you will increase the solid content, okay, as you will increase the salt concentration, these ions will increase, and these ions, if this ion will increase, this will increase the capacity of your buffer. Okay, this will increase the strength of buffer. Like if you will add 50 molecules of HCl, 50 molecules of NaOH, still they will able to maintain the pH. Okay, and one more thing, suppose you have added this like, let me clean this. Okay, suppose you have prepared ammonium formate buffer. Okay, you have dissolved ammonium formate in a particular, like you have prepared 10 millimolar of ammonium formate. Okay, but if you have prepared 10 millimolar ammonium formate, so as said, the pH will be around 6 to 6.5. But if you want to reduce the pH like by 4, so by which acid, or by which acid you can reduce the pH? If you are going to reduce the pH by HCl, so it will reduce the pH, but what will the problem? It will reduce the capacity, it will reduce the buffering capacity of your buffer. So instead of this HCl, we can use this formic acid. So what will happen if we use formic acid? So once we will add formic acid, so formic acid will dissociate, and because of it will dissociate, and it will give like this format ion and this H plus ion. So because of this H plus ion, the pH will reduce. Okay, and because of this format, your buffering capacity will increase, your buffer capacity will increase. In case of you want to increase the pH of this ammonium format, similarly you can take ammonium hydroxide. What will happen? Ammonium hydroxide will dissociate into the ammonia and hydroxyl ion. So this, because of this hydroxyl ion, the pH will increase, and because of this ammonia, your buffering capacity will increase. Hope you guys will understand. If you have any query, you can ask. So what is the importance in HPLC? What is the importance of buffer in HPLC? It controls the analyte ionization. Like in second or third slide I told you why this ionization, controlling of ionization is important. Like we want, like most of the molecule, either it should be in ionized form or unionized form. Okay. Buffers improve the peak shape and symmetry. As they will be in one form, it will behave like only one compound. They will have only one physiochemical property. It will ensure the reproducibility. If you are using buffer, in buffer you will get reproducibility and same retention time. It will also protect the column. So buffer strength is equal to buffer capacity. If you are using 10 millimolar, so it is having less capacity. Okay, if you are using 5 millimolar, 10 millimolar, if lot of drug molecule is getting ionized, so it is not able to, the buffer will not be able to handle that much pH change. So because of that, it may change the pH. So buffer strength you can increase by taking 10 millimolar, 20 millimolar, 30 millimolar, 40 millimolar, 50 millimolar of solid content. As you will increase the solid content, stronger buffer you will get. Like in HPLC, people are using from 10 to 50 millimolar of buffers. So there are common HPLC buffers like the phosphate buffer. They are not MS compatible because they are not volatile. So in mass spectrometry, mostly volatile buffers are used, like this acetate format and acetate buffers. This MS compatible over like ammonium acetate, ammonium format, formic acid and acetic acid. How to choose a buffer? Like initially I told you, if your drug is having, like if your buffer, suppose I have taken ammonium format now, so it is having a peak, so we should choose the buffer in a buffering range. Suppose I am having ammonium format, so that is having the range of from 3.5 to 4.5 I think. So we should keep the pH in between that. And another thing we should choose, like if you are using UV detector, so in UV detector we can use phosphate buffer and etc. Like we can use volatile as well as non-volatile buffer. But in case of mass detector, we can't go with phosphate buffer as it is non-volatile. Another thing, solubility in water and organic. Like if I'm using phosphate buffer, the problem with phosphate buffer, we cannot use, like we can use with acetonitrile, like it is having very less solubility in acetonitrile. So if you are using phosphate buffer like 20 millimolar of phosphate buffer, and if you are using ACN, so you cannot go in 20% of phosphate buffer and 80% of ACN, because in this composition this salt, this phosphate buffer will precipitate in that mobile phase and it will clog the tubing. Okay. And stability and column type, based on stability, like and column type we should choose the buffer. Like column compatibility also an issue. How we should prepare buffers? We should take HPLC grade of salts. We should not use like general grade. We should take high purity HPLC grade salts. Okay. After preparing buffers, we should filter it, and degas is generally 0.22 is very good, but as per guidelines people are recommending like 0.45 will work. 0.45 micrometer will also work. Before running into the column we should degas it, and like before running into the column we should adjust the pH. We should label it with the pH, concentration and date. So this is all about the buffers. If you have any question you can ask, feel free to ask the question. Thank you very much. And these are the common mistakes. Okay, like people, they do not check the pH. Okay, and sometimes people use phosphate buffer in a mass kind of detector, so that is not recommended. So make sure which buffer you are using, it should be compatible your detector. Like as I told, like phosphate buffer you should check like in which concentration, in which ratio of aqueous phase your buffer and organic phase they are getting precipitated, you must check. And we should not use expired buffer. So these are the common mistake we should think about it. So this is it as of now, and these are troubleshooting. Like if you are getting peak shifting, so there may be a pH drift in your mobile phase. If you are facing peak tailing, like it could be due to insufficient buffering or pH mismatch. If you are getting ghost peak, like your buffer is getting contaminated. And if you are getting higher back pressure, column back pressure, like 300 bar, 400 bar, so that could be due to the salt precipitation in column and tube. Thank you very much. So if you have any question you can ask.